All right, let's move right into reaction number 4. I have some calcium carbonate, and I'm just going to read right from the lab. It says, place a small amount, about the size of a jelly bean, which there's a lot of sizes of jelly beans, so keep it small, right? So I like to think of the size of a pea, about that, or the end of your finger. So in a clean, dry test tube. So I'm going to do that. I have a clean, dry test tube. Take a little bit of that with my scoopula. Put some in there, about the size of a jelly bean. Using a barrel type pipette. I'm not going to lie, I didn't grab a pipette, and I'm not going to go get one. Oh, just kidding, I do have one here. It says to add some 1 molar hydrochloric acid. Don't you love my old-fashioned label? I think that could be updated. Don't tell anyone. So this is just a white powder. 1, 2, 3. Boy, this isn't even 40 drops yet. Can you see that reaction? I have a pretty short pipette, so this is taking one. This, my friends, is chemistry. This is the cool part. Wish you could be here doing this. It's a little like that baking soda and vinegar reaction, if you've ever done that. So yeah, I'm going to have a little bit more. And then it says, you know, feel the sides of the test tube, observe the reaction. I could have measured a little more carefully. All right, so anyway, we see lots of fizzing. I see a slight temperature increase. I feel like it's not what it was with the hydrochloric acid and magnesium. It's just very slight. Lots of bubbling. If I shake it and stir it, a little bit more bubbling. And then it says, light a splint. I gotta light my Bunsen burner and see what happens when you put a lighted splint in this one. Quickly light a splint and insert the beginning about halfway down. Lighting my splint. So watch what happens. Doesn't appear to be burning. Again, it appears like, get some of my flame part off. It goes out right away. We see the smoke, I think, just from the splint coming out of there. Let me get this shut off. So again, think about the gases that might support combustion. This ain't it, right? Because it goes up pretty quickly, so we know it's not that. And we did, again, slight increase in temperature from that reaction. Not nearly what we had with the magnesium in there. And that's it for reaction number 4. All right, moving right along. So we are at reaction number 5 of 8. So reaction number 5 says add about 2 milliliters, 40 drops of copper 2 chloride. Use that test tube. I'm going to use a clean one, but I want to get that cleaned out. So my copper 2 chloride, I'm just going to set up maybe, I never thought I'd be too tall, but I'm a little too tall for this video. All right, so my 0.5 molar copper 2 chloride, and it says 2 milliliters, about 40 drops. I'm going to estimate, I can get pretty close with that. And the amount doesn't matter. It's such a pretty blue color. I just love, you know, copper compound, copper chloride, copper sulfate. Just have that very pretty blue color. Then it says to take some mossy zinc and see what happens. So mossy zinc, and this isn't very reactive. I could grab it with my hands. I'm looking for a piece that's small enough to fit in the test tube. I am going to use my fingers. Okay. Here we go. mossy zinc, it's just little gobs of this metal, you know, not super shiny metal. And lab number 5 says 1 to 2 pieces. This is a pretty big one. I'll see if I can put another one in, but I'm just going to drop it in there. And at first, sorry, trying to find the camera. The first thing I notice is it kind of turns dark right away. Okay. Not really sure why that's happening. We might want to think about copper 2 chloride. Sorry, I'm really bad at this. It moves the opposite direction. So first of all, I'm easily confused anyway, and then I have this opposite direction thing, so I got that going on. Anyway, so we dropped copper 2 chloride into, we dropped zinc into copper 2 chloride. So I want you to think about, this is a single replacement reaction. So if you, when I shake this, I'm going to shake a little bit and then I'm going to show you, do you see all the stuff collecting on the bottom of this? Have all this sediment. So thinking of putting zinc in a copper 2 chloride, there I go again, losing your experiment for you, copper 2 chloride solution, based on the activity series, what do you think is happening? But your observations, we're going to keep going with this because I think, do you notice a change in the color of the solution a little bit? We're going to keep going until it's super obvious. I'm just shaking this because it appears that there's particles collecting on that zinc, and I have to shake it off of there so that I can clean the surface of the zinc off, so that I can, oh, this is also warm. Okay, this is also warm. So this one's taking a few minutes. I don't know if you can see even the color of the stuff. At first it just looked dark, but now it has a color indicative of a very common metal. That would be worth writing in your observations, because after you're done with all of these observing the experiments, you have to predict the products. That's why it's so important to make these detailed observations, write down exactly what you see, what evidence you see, so that when we're finished, we can go through and what do we think happened? What was really going on there? That's important. This is the fun part of chemistry, right? You've done a lot of math. You've done a lot of math. I feel for you. I understand. A lot of balancing equations. For some of you that's really easy, but for some of you it's not so much. You know, we all have different strengths, and that is okay. Nobody asks me to be an art teacher. No one asks me to be a social studies teacher. That's a good thing. You don't want me to do that. I will ruin you. All right. So I'm shaking this. It's still reacting a little, but look at this solution. This is cool. What was this color certainly isn't that color anymore. So we know a reaction has occurred. And look at all of that sediment on the bottom of this test tube. I still see it's a little cloudy with some bubbles, so the reaction is still occurring. I still have, it seems like, sediment falling off my piece of zinc. So this is interesting, kind of what has happened here. And again, single replacement reaction. So you know, you'll have to make predictions about what you think the reaction was, and what you think was produced in that reaction. So I think that's it. I think we're about done. When this is completely done, this solution will be almost clear. It should be pretty clear. So that's what we were kind of looking for. The zinc, the zinc's not that, you know, that shiny shinier or more silver kind of color, that seems to be gone. And it's because of that precipitate that collected on the outside of it. So again, write down all of your observations. I think we'll stop right there for today, or for this recording. So that was reaction number 5. So we have 6, 7, and 8 left.